Welcome to the world of mechanical keyboards and macropads. In this video you'll learn how to build them. First of all, why would you even consider building a keyboard yourself? Well, beyond the cash saving benefits, there's the fantastic world of automation waiting for you. Now picture this, you wake up, eyes half open, and all you need to do is get those 3D printers up and running. Before it was like a marathon of button pressing, but now just press this one button and all printers are up and running in no time. Let's take a look at another example. Every time I want to list a new product, I have to type out all of the available colors, while making sure that they're all spelled correctly. Now, with just a single button press, all colors are listed in seconds, no typos involved. There's a ton of things you can do, and I'll explain macros in more detail after the Macropad is built. There are two main firmwares you'd want to consider: QMK and KMK. QMK, the firmware I'm going to use today, is mostly AVR based. On Arduino Pro Micro works well. It's a bit easier to get started with, but it doesn't have as many features as the KMK firmware does. The RP2040 IC has more pins and memory, meaning that you can add more keys and store more macros on the keyboard. QMK is overall easier to get started with, so for first time builders, I'd stick with QMK. Let's take a look at what we actually need to get started. First of all, the microcontroller. I'll be using an Arduino Pro Micro board. It has the Atmega 32U4 IC, which is HID compatible, and that's very important. Arduino Uno, Nano and others won't work. It has to be a Pro Micro. Next, we need something to press. I will use blue mechanical keyboard switches, but any momentary switch will work. The only two requirements are that the switch is a momentary one and in normally open configuration. If I was to connect each switch to a separate I/O pin on the microcontroller, I could use only 16 switches, which is obviously not enough. To use more switches with less pins, we connect them in a keyboard matrix. I'll explain the matrix in more detail in the schematic part of the video, but for now, all you need to know is that every switch requires one diode for the matrix to function right. I'm using 1N40148 diodes, and as I said, one diode per switch. Every time you want to flash the board, you need to connect the reset pin to ground, so to make that easier, I'll use one micro switch so I can reset the keyboard when it's all assembled. Besides these main components, you will need some wires. They won't be carrying lots of current, so you can use thinner ones, something like 28 gauge. If you decide to go with my enclosure, you will need 4 5x5 M3 inserts, 4 M3x12mm countersunk bolts, and 4 8mm rubber feet. At this point I was planning to use some M2 screws to secure the micro switch, but as you'll later see, they won't be needed. All of the parts are linked down below, and if you want to support this channel and help me make these videos more frequently, consider getting the parts from my links. The enclosure is linked down below as well, and if you don't have a 3D printer and your friend doesn't have one either, you can get the enclosure directly from me. At this point we have everything we need, and now it's time to connect it all together. I made a schematic to show how everything is going to be connected. On the left side is the Arduino Pro Micro with the switch for reset, and on the right are the switches. Arduino labels the pins differently from what they're actually called in the microcontroller datasheet. In code, QMK uses the actual AVR labels, so it's important to remember that. You can see that each pin has an AVR and an Arduino name. All switches are connected in a keyboard matrix, which leaves us with 4 column and 5 row connections. You can see how the switches are labeled from 00, 01, 02, 03, then the next row is 10, 11, 12, 13, etc. Take note of these two, because it's going to be used later in code as well. Connect everything as shown here and be careful about the diode polarity. Anodes connect to the column rails and the cathodes to the row rails. Diodes are marked with a black circle on one end, and that is your cathode. I'll take the plastic enclosure and remove the plate from the housing. Each switch is press fit to the plate. Don't put the keycaps on just yet, because we need those 4 screw holes accessible until we screw everything together. After all switches are in place, I'll start wiring the keyboard matrix. The schematic shows the top view, so in the end you should have wires hanging from the top and left side of the plate. Take the diodes and cut the anode leads to size. They should be around 5 to 8 mm long. pre-tin each switch and each diode and connect them together. In the end it should look something like this. Then you can bend the leads like this so that they make the row connections. Solder them together and your rows are done. For columns I take some silicone wire and cut pieces of insulation like this. Solder each row to the row side of the switch and the matrix is done. I'll extend all of the wires so they can reach the Arduino. If you made it this far, you're almost done. This was the hardest part of the build. I'll take the bottom shell and install the 4 inserts. Arduino can be put in place and secured with some super glue, and the micro switch is held with 2 M2 screws. First and easiest connection is the reset switch. One wire goes to the reset pin and the other to ground. Then take the column wires and wire column 1 to Arduino D2 pin, column 2 to Arduino D3, 3 to 4, 4 to 5. I realized that my D5 pad is broken, so I'll have to use another one. Just 5 more wires to connect. Row 1 goes to Arduino D6, row 2 to D7, row 3 to D8, 4 to D9, 5 to D10. And that's it, everything is connected. The M2 bolts I used to secure the micro switch were too tall, and the plate couldn't be inserted all the way in. Countersunk screws would be a better choice, but I didn't have any on hand, so I secured the micro switch with some super glue and removed the screws. To start coding with QMK, you will need a couple of things installed. First thing is QMK MSys, and the other one is QMK Toolbox. QMK MSys is used for coding, while the Toolbox is used for flashing the microcontroller. GitHub links are down below. After everything is installed, open QMK MSys and type QMK new keyboard and press enter. Then it asks you for the keyboard name, and I'll name this one Jumbo 4x5 Macropad. Then it asks you for your GitHub info. Enter anything you want. After that, we need to enter the keyboard type we are using, but since this is a custom one, select none of the above. And the last thing, we need to select our microcontroller. Arduino Pro Micro uses the Atmega 32U4. And that's it. The script has successfully created a new directory with all required files that are needed to start programming our keyboard. In the top address bar, type cmd, then code space dot. This command will open our folder inside VS Code. At this point, we just want to confirm that everything is connected right. Open the info.json file and start editing. I'll change the manufacturer and maintainer name. Keyboard name is the name that shows up when you connect the keyboard to the PC. I'll name mine Janjetina 4.500. Set the bootloader to Katerina and diode direction to call to row. I'll disable boot magic, and now it's time to enter the call and row pins. You can copy mine, but the last call pin is different, since my Arduino D5 pad was broken. I set it to B1, but if you were following my schematic, set it to C6. Just one more thing to do and our info.json file is finished. We need to define each switch on the matrix. To do this, I'll delete everything except the first line and copy it 3 more times. This will be our first row. The first 2 numbers set the switch and the other 2 are written in reverse. Now copy this chunk of code 4 more times to make 5 rows and edit the following as shown. Info.json file is done, and now let's move to the key map C. First of all, I'll delete all comments. QMK keyboard H is already included, but since I'll be doing some more stuff with this keyboard, I'll include Croatian key maps as well. And here we have the keyboard layout again. Make sure it's the same name as in the info.json file. 4 columns and 5 rows. KC0, for example, makes the keyboard write 0 when you tap the key. Since this is just a test to see if all keys are working, I'll make it work like a numpad. The list of all keys can be found in the keycodes overview section in the GitHub page. After writing the keycodes, it's finally time to compile the firmware. Save everything and open QMK MSys again. Type QMK compile, keyboard, followed by your keyboard name, KM default. After that's done, the script will create a hex file inside the QMK folder. Open the QMK toolbox and select the hex file. Select your MCU from the drop-down menu, and I like to set auto flash option. Then connect the Macropad to the PC and toggle the reset button. The flashing will start automatically and it will be done in a few seconds. After flashing is complete, you can go to any keyboard testing website and test each key. If everything is working as expected, you can close the enclosure, screw the 4 screws and put the keycaps on. For labeling the keycaps, I use my label printer and cut small pieces to size. I'll look more into sublimation in the future, but that requires special paper, a new printer and special ink. At the beginning of the video I showed you some pretty cool macros, so let's take a look at how to write them. Go inside your keymap file and add the custom keycode section, just like this. This can be named however you like. I'll create a simple example to open the calculator. Then we can assign this custom keycode to one of our switches. And under the keymap, let's create a case which will check if one of our custom keycodes is pressed, creating a case calc and ending it with a break. If the key was pressed, I'd like to send a string. Hold down the left Windows key, press R to open run, and release the left Windows key. Wait for a moment and type CALC followed by pressing enter. Let's save, compile and flash the firmware and see what happens. And as you can see, pressing the switch opens the calculator. You can play around with this to make the macro you actually need. You can flash the Arduino as many times as you want and it's practically impossible to break. If you want to get one of these enclosures for free, subscribe and comment something like Janiti na 4.500 and I'll be selecting a few of you next week. If you have any questions, leave them down below, and if you decide to go with my design, consider getting the parts from my links below. You can download the enclosure from Printables and Thingiverse, but if you don't have a 3D printer, you can buy this enclosure directly from me. If you'd like to see these videos more often, you can support me on Patreon. That's it, have fun keybing and see you in the next one.